Okay, good morning, students. So we can start the lecture now. We have to start, we have to continue the discussion that we had about network devices, right? So we finished our discussion about this physical address, logical address, and then I explain you this example how a packet travels through networks and then goes from source to the destination, right? And after that discussion, we started about network devices, right? So network devices, two types of devices we discussed, modem and repeater, right? So I told you modem is now very rarely used. It is used to use the normal telephone network for data communication, and now we don't use that. And then repeaters are used if you are sending a signal over a large distance through a cable. After some distance the cable will get weak, right? So there will be a lot of distortions and all that. So then according to the cable type you are using, after certain distance limit there will be deterioration in the signal. So then we use a repeater to regenerate the signal and pass it back. So both these modem and repeater are layer 1 devices. Layer 1 devices means they don't have any intelligence. They will just do a physical operation for the signal, right? So what is the meaning of that signal? What are the data contained there? What are the addresses that is in the signal data? They are not aware, right? So they are not concerned about that, because that is not part of the job of the modem and the repeater, right? And then we come to the one of the main network devices that we use today, right? So which is called hub. We didn't discuss anything about the hub that day, right? I think I stopped at the repeater, right? So hub is usually can be called as a multi-port repeater, right? So what the hub does very basically is, let's say now, let's take this example where you have a hub and then there are several devices connected, a printer, server, and some computers, right? So now let's say a server is sending some data to this computer, right? So actually the server wants to send some data to this computer, right? So that is the requirement. So what does the server do? Server will send this data to the hub. So what does the hub do, right? So when server is sending the data, it will put as the next hop address this address, right? Let's say A is going to send it to B. So in the packet or in the frame, the server will put as the next hop as B, right? So because this should first, the immediate next stop should be B, right? So it will send it as B. So then the data actually should go from the hub to the client to B, right? But what will happen is this data sent by A will go to all these ports that is connected to the hub, right? So what the hub does basically is, if somebody sends a message, it will send a copy of that message to all other devices connected to the to the hub, right? So it's basically a multi-port repeater. Why do we say that? When you get something, you will repeat or copy that signal to all the other ports that is connected to the device, right? So it regenerates data and broadcasts them to all ports. So you take the data, copy it, and then broadcast means send it to everybody, right? So hub can be only used to connect a very simple network, right? So for example, if you are having, let's say like this, about 4-5 devices, you can use a hub to connect. But why can't you use a hub to connect about 100 computers together? What will be the issue? So somebody sends data, it will send a copy to everybody. Another one sends data, it will send a copy to everybody. So what will be the issue if you use a hub to connect large number of devices together? Yes? Any guesses?
It may be data transfer speed.
Sorry?
Yeah, it may data transfer speed may be low.
Will reduce, right? Yes, because now when you send one data, it will be copied to everybody. Again, another data, again it has to be copied to everybody. So it will be like a lot of traffic will be there, and because of that data transfer speed will be very low, right? So, and the other thing I want to tell you is, now let's say you send this packet to with the address, next stop address as B to everybody, right? So then when this person sends it, what will happen? C, D and E also gets it, no? Right? So when C gets this frame, it will look at what is the next stop. Next stop is B. So it's not for me, so it will disregard, right? So all other devices that is not supposed to get this message will disregard it looking at the next stop address, right? So that is what will happen, but actually everybody will get the message, right? After getting the message only they can disregard. So because of that, if you use this kind of arrangement for large number of computers, then there will be a lot of data traffic and the speed will go down, right? So because of that, you can use this kind of hub only when you want to connect few number of devices together. So we say the device does not have any intelligence. Can you tell me why? Why do we say that? We say the hub don't have any intelligence. So from the operation of hub, why we can say that it doesn't have any intelligence?
Just only transferring the
Yes.
data, because only the transferring the data.
If it have an intelligence, what can he do? What can it do? Now this A is sending a frame, right? So there is a next stop address written in the frame. Now the problem with hub is what? Why does hub cannot only send it to B?
Because it's on
Sorry?
hub been on the same time. Everyone gets their message,
Hub is?
because when the server send the message
Mm,
to the hub, the
mm,
other devices are connected to the hub, so everyone got their data.
not very clear what you are saying. When the hub say, when the server sends the message to the hub, okay,
Then after that, the message is sent to everyone,
everybody, right? Why does this hub send it to everybody? Now there is an address, no? Why does the hub send it to everybody?
because it cannot identify where the
Right, right, very good, right? So that is why we say it doesn't have any intelligence. So it cannot, from that message or from that signal, hub cannot identify that next stop address, right? So it doesn't have the layer. Which layer? Next stop addresses can be identified by what devices?
layer
Which layer is responsible of next stop
layer 2.
delivery? Layer 2, right? So that means it doesn't have the capabilities of layer 2. So it's only a layer 1 device, right? So it cannot at least identify the next stop, right? Remember when we talked about that data transfer, right? So you have the message getting from upper layer, right? And then layer 3 adds final destination details, right? So it has final destination details, right? And then this message, the whole message is taken as another block, and then layer 2 adds, right? So layer 2 adds some additional information next hop, right? So it is responsible of next hop, right? So any layer 2 device can read these next hop addresses, right? So because this is added by layer 2, these next hop addresses can be read by the layer 2 devices, right? Now hub B1 cannot read this part, right? The final destination is here, right? So to read the final destination details, you need a layer 3 intelligence. But if you have layer 2 intelligence, you can read the next hop addresses, right? But hub B1 cannot do that, right? So that means it's a which layer hub belongs to.
One layer.
If it cannot read the layer 2 information, means it's what layer device?
Layer 1 device.
Layer 1, right? So it's for the intelligence is more less than even the layer 2 device, right? So it cannot actually read anything. It will just copy whatever the 1010 signal to the other ports, right? So that is what the hub will do. So that means hub is a layer 1 device, right? So anything to clarify about this operation before we move to the next part? Right. So then we are going to discuss, or we are going to learn a new concept. So the problem of hub, as I already told you, If more than one node attempts to transmit data at the same time, a collision can occur. Now what will happen actually here is this. Now let's say this A is trying to send some data to B now, right? So, right, A is trying to send some data to B. So A will send that data and this data will go to everybody, right? Let's assume at the same time, right? At the same time, B is trying to send some data to C, right? So B is trying to send some data to C. So that frame will go from B to the hub, right? And at the same time, let's assume this A's message is also coming to B, right? So then what can happen? No, we'll take another different example. Right. So let's say C is trying to send some data to D, right? So that is the requirement. So C is sending this data. And at the same time, this A message is also coming to C, right? So what will happen here? So basically it means there is a cable, right? So one voltage signal, 1010 digital signal is coming this way. And then from this end, another some 10 message is coming, right? So what will happen here? When these two voltages are coming through the same cable, what will happen? What will be the final result? Yes?
Overlap.
Yes, any idea? What will happen?
It getting bigger.
Can you speak a little bit louder? I can't hear you properly.
It
Yes?
can be zero.
Yeah. Zero, whatever, we don't know, right? So you have to add these two voltages together and then there will be some resultant voltage, right? But will that have any meaning? Now this is trying to send some information here. This is trying to send some information here. These two voltages will add up, right? So we say the two packets collide. Collide means they like meet with each other and then get distracted, right? So then finally some voltage will be there, but that will not have any meaning, right? So that means this message sent by C to hub and the message sent by hub to C, both will get lost, right? So this is called data collision, right? So what data collision happens in the same path, two devices are trying to send the data at once, right? So this can happen a lot of time, right? But if you are using a hub specifically, the probability of getting this is very high, right? Because now let's assume if uh, if this didn't happen, right? If A's message is only sent to B, right? At the same time, if C is trying to send something, there won't be a collision. Why? Because hub is not sending the data to C, no, it will only send to B. So then when C can always send data at the same time without getting any damage, right? Because A message will only go to B. Now with hub operation, what will happen is, right? So it will go to everybody, right? So then the probability of getting collision will increase, right? So get my point? So when hub is copying all the one message to everybody, the probability of getting this data collision is more. Why? Because at the same time there is a possibility that other end devices is also trying to communicate to hub. But if a hub only send this A's message to B, then only if B tries to send the data, there will be collision. Otherwise, there won't be any collision, right? So basically, the problem with hub is the probability of getting data collision is more, right? Data collision more means you get lot of data losses. So when you have a data loss, again that device will try to send the same message to the device, right? So when there is a data loss, the device sender can identify that and the sender will send it again and again. So because of this, there will be a lot of data traffic and data losses, right? There can be a lot of issues. So that is the problem with the hub. So because of that, we use the hub only when there are very small number of devices, right? So that is what is mentioned here. If more than one node attempts to transmit at the same time, a collision will occur, right? So that is what I explained. like this, there are two voltages. When two voltages come in the same channel at the same time, this kind of data destruction will happen, which we'll call a collision, right? When a collision occurs, data from each device impacts and are damaged. So you will lose both messages sent by both people. So then you will have to send that messages again, right? So that is the problem of hub operation. Now we are going to learn a concept. This is not only for hub, but common for every all the devices, right? Something called the collision domain, right? So please listen to this properly, because this is something important, right? So collision domain is the part of the network when two or more nodes transmit at the same time, collision will happen, right? Collision domain is the part of the network when two or more nodes transmit at the same time, collision will happen. If the numbers of devices increase, number of collisions increase, which will create a huge data loss, reduction of the speed, right? Now let's take an example and try to understand this, right? So let's say A and B computers, right? So let's say A is trying to say, sorry, it's already B, no? So we'll take this as C and this is D, right? Let's say A is trying to send some message to B, right? So this is a hub, right? This is a hub. So when A is trying to send some message to B, what will happen? The message sent by A will go to which computers? When A is trying to send some message to B, and if this is a hub, this message will go to which devices? Yes,
To
A's message. Yes,
hub.
it will go to hub and then go to where? It will go only to B, or what will happen?
For every computers.
Sorry?
For every computers.
All the computers, right? It will go to C, D and B, right? So let's assume when A is trying to send a message, at the same time D is also trying to send a message, right? A is trying to send a message, at the same time D is trying to send a message. So A's message will go to the hub and then it will get to this path, right? It will come to this cable. At the same time D will also try to send, right? So if A is faster than D, the two messages will collide here, or if D is faster than A, then the two messages will collide here, right? Somehow you can see when A and D are trying to send a message at the same time, there is a possibility of getting a collision. Is that clear? Right?
Yes.
A is trying to send a message. So A is sending this to hub and then it will get copied to here. At that time, if D is also trying to send a message, either at this part or this part, there will be a collision depending on which one is faster, A or D. Right? So anyway, when A and D are trying to send a message simultaneously, there is a possibility of getting a
Correct.
collision. Right? Is that clear?
Yes.
Yes, right? So then that means, so we say A and D are in one collision domain, right? If two computers are trying to send a message at the same time, not to each other, but to some other people, right? So A is trying to send to B, D is trying to send to C. So if two people are trying to send each other, definitely there can be collision. I'm saying not like that, to somebody else, right? So A is trying to send to B, D is trying to send to C. At that point, because of this hub operation, there is a possibility that when A and D is trying to send simultaneously, there can be a collision, right? So that means A and D are in one collision domain, right? So collision domain means a part of network we are trying to identify. Then let's assume A and C. If A and C is trying to send messages, will there be data collision? Let's assume A is trying to send to B and C is trying to send to D. Can there be a data collision? Is there a possibility?
No, madam.
Yes or no?
No.
Why? Let's say A is sending a message, right? So to B. So this message will go to this person, and this person, right? So C is trying to send a message to B. So that will go like this, right? At the same time, I mean, same time means there will be some person sending somewhere like there will be some difference of time, no? So C is sending a message. So either at this place, or if C is faster at this place, there can be a collision, right? The same thing with A and D will happen with A and C. Is it clear? So A and C is trying to send messages simultaneously, right? So A send a message. This red color message is sent by A. So that will be copied to C, B and D. So at that moment, somewhere in that moment, C is also sending the message. No? So either collision will happen here or collision can happen here. Right? But there is a probability when A and C are trying to send data at the same time, a collision will happen somewhere. Is it clear?
Yes, madam.
Same example as A and D, right? Nothing different, no? A and D and A and C and A and B, everybody same, right? So that means A and C also will be in the same collision domain. So A and B again same, right? So if both of them are trying to send messages simultaneously, there is a possibility of getting a collision, right? So that means A and B are also in the same collision domain. So finally we can conclude all the devices that is connected to a hub will be in one collision domain, right? So A, B, C and D will be in one collision domain, which means if any of these two devices are trying to send data simultaneously, there is a possibility of getting a data collision, right? So that is the situation, right? So then, so we call everybody, all the devices that is connected to a hub belong to one collision domain. One collision domain means if one device and the other device are trying to send data simultaneously, there is a very big possibility of getting a collision, right? So is it clear? Any questions? Anything you want to clarify? So the concept of collision domain you have to learn here. So from device to device, the collision domain will change, right? So collision domain means any part of the network where when both of them are trying to send data together, there can be a possibility of getting a collision, right? So in a hub situation, when you are connecting devices through a hub, everybody connected to the hub will be in a one collision domain, right? So everything is clear. So then we'll move to the next one, right? Then there is another one called broadcast domain, right? So what does the usual meaning of broadcasting? What is the meaning of broadcasting? When you broadcast a message, that means what?
From one location to send data everywhere.
Sorry?
From one location to from one location to send to others.
Send one person to another person. Is that broadcast?
No, madam. I think I said that, ma'am. From one location to others.
Others, right? So multiple number of people, no? Usually do we have a control of which people we are sending the message? Now let's say we are saying TV broadcasting, no? So TV broadcasting. Now does the TV station know to which how many TVs will watch their channel? They have a control?
No.
No, right? So if the TVs are within the coverage area, everybody will be able to send the signal, right? So usually broadcasting means you send it to everybody, right? We don't say to multiple people because there is another word called multicast. So multicast means you send to selected number of people, or not only one person, right? For example, if we take this example, if you send a message to B and C, right? We say it's multicast because you are selecting some number of people and send. Or you send it to, let's say there is another device here called D, right? And this is E. So you send it to B, C and D is called a multicast. So because you are in control of sending that message to, you know to which people you are sending, but you are sending to many. So that is called multicast. Broadcasting means we say, okay, send this to everybody. We just say send this to everybody. So everybody there will get it, right? We don't have a control whether these 5 people, 6 people, we don't know, and we are not concerned. Sender is not concerned how many people will get it or who are the people will get it. Say, they will send to everybody, right? So that is called broadcasting. So there is a way in networks for special reasons we send data through broadcasting, right? There are messages called broadcast messages, right? So when you especially when you want to inform something to the other people, right? Inform something to the other people, you just send a broadcast message. For example, let's say this A computer got connected to this network for the first time, right? A has been connected to this network for the first time. So he wants to send a message to other people. Hi, I am A. My MAC address is this, right? So that is required. Usually the computers in the network, the other people who are connected to the network should know each other's MAC addresses. That is required. So when one device connects to the network first time, it will send the message, okay, I am A, my MAC address is this, right? So that message is intended to everybody, right? You want to send that message to all. So that kind of messages we call broadcast messages. So then you don't put a next stop address specifically. You put a special address which will tell the network devices that this has to go to everybody in the network. Understood? So usually if you want to send a message to one person, you put that person's address, right? So let's say you want to send this to A. A wants to send a message to B. So we put B's address and send, right? So then it's a normal message. Broadcast message means if you want to send some information or share some information with everybody in the network, then we send a broadcast message. So there you cannot put a next stop address. Why? Because this should go to everybody. So then there is a special address, right? There is a special broadcasting address. So you put that address and send the packet. So then everybody in the network know, okay, this message has to go to everybody, right? So that is the meaning of broadcast message. Now, let's assume this is a hub, right? This is a hub. So let's assume A is sending a broadcast message, right? A is sending a broadcast message. So who will get this broadcast message? Let's take this as D. Who will take the broadcast? Who will get the broadcast message? Can you name the devices that will get the broadcast message?
B, C, and D.
B, C, and D, right? Everybody will get. Now, because it is a hub, right? So you don't see any difference because anyway, if you get a message from A, everybody will get it, right? But if it is a broadcast message also, uh, even though this is a hub or not, everybody will get it, right? But in a hub, also in hub situation also when one person send a message, all these computers will get the message, the broadcast message, right? So there is another name we have to learn, broadcast domain. Broadcast domain means will be the part of the network where each device can see each other's broadcast messages. For example, if A sends a broadcast message, if B, C, and D get the broadcast message, then that means all these 4 devices are in one broadcast domain, right? If A send the broadcast message and then B, C, and D will get it, right? So which is the case in this situation if this is a hub, right? So when A send a message, if B, C, and D gets the message, that means all these 4 devices are in one broadcast domain, right? So in a hub, if you consider devices connected to a hub, all the devices will be in one broadcast domain and also all the devices will be in one collision domains, right? So when we discuss the other network devices, you will learn later this collision domain and broadcast domain is not always the same, right? Because of this hub operation, how the hub works, only these two have become one, right? But usually that is not the case. So for a hub, usually all the devices will be connected to the collision one. All the devices connected to the hub will be belong to one collision domain and one broadcast domain. Okay, so is it clear? Any questions? So we say hub creates one broadcast domain and hub creates one collision domain, right? So all the devices in one connected to one hub will be in one collision domain and also in one broadcast domain, which means all the devices when one sends a broadcast message, all other people will get the broadcast message. And also, if any two devices in the hub tries to send messages simultaneously, there can be collision problems. So I hope it is clear. Any questions before we move to the next one?
No, madam.
Right. So then next one is bridge. Right. Next network device is called bridge. So bridge is a device that, sorry. So this is a bridge. Right. So how many inputs it has? I mean, how many ports it has? Two. Usually you have two ports, right? We say input and output port. So you have two ports in a bridge, right? So used to isolate network traffic and computers. Has the intelligence to examine the incoming frame, source and destination addresses, right? So that means you can see frame. No, frame means usually frames are layer 2, right? So frame means layer 2. So layer 2 addresses it can identify, right? Layer 2, that means next hop address and the next hop source it can identify, right? Now let's say A is sending, right? A is sending a message. So which will go to hub 1. Then hub will send this to whom? Hub 1 will send this to whom? Let's say A wants to send a message to B, right? A wants to send a message to B. Right. So A will send this message to hub 1. So the message will go to whom? To whom this message will go? Yes? What can you say? Now A is sending a message, right? This is a hub. So A is sending a message to hub. Now to whom this hub will send the message?
Host B and bridge.
Host B and bridge. Very good, right? So it will send it to everybody that is connected. That means it will be sent to B and it will be sent to bridge, right? So then let's look at what the bridge do, right? So that is the thing. So bridge works at the media access control, that means MAC, layer 2 of the OSI model, right? So routing table is built to record the segment number of addresses. If the destiny, so before that I will just explain you what will happen. So when the bridge gets this, right? So when the bridge gets this, right? Bridge can look at the layer 2. That means next hop addresses, layer 2 addresses, bridge can identify. So bridge will identify the layer 2 address, right? So what is the layer 2 address of this message will be? Layer 2 means next hop, no? So when A send a message to B, what will be the next hop address in that packet or frame?
B.
A is B, right? Very good. It will be B, no? Because A wants to send this to B. So it will put the next hop as B and send. So the packet, the frame that is going to this bridge will have the next hop address as B, right? So bridge understand or bridge knows that B computer is connected to this part, right? So he knows B is here in this. Now bridge has two sides, no? He has side 1 and side 2, right? So bridge knows this B is in the side 1, right? So if he knows that, will he pass this message to the other side? What do you think? No, right? Because bridge knows this B compute is somewhere in this part, this side 1, right? So let's take this as side 1. So it is in the side 1. So then if the message is coming from side 1 addressed to B, no point sending is here to side 2 because he knows that the device is in the side 1, right? So this yellow color message will not pass this side, right? So if it is a hub, it will send it to everybody, right? So the bridge has the intelligence to know that if I get a message from this side 1 or input 1, because B is also inside 1, I should not copy it to the other side, right? If it is not the address that is inside 1, it will definitely copy it to the other side. Let's say A is trying to send a message to C, right? A is trying to send a message to C, so A will send it to hub and hub will send it to B and bridge, right? Now when the bridge receives it, it can look at the next hop address, it is C, right? So bridge knows C is in the other side of my network, right? So then it will copy it to C. Is it clear? What is happening? So bridge basically have an idea which devices are connected in which side of the network, right? So then it will not unnecessarily copy the data to the other side like the bridge does, right? So sorry, hub does. So bridge has the capability of sending and stopping unwanted data going to the other side. Okay?
Excuse me, madam.
Yes.
Bridge එක hub 2 වලට දුන්නට පස්සේ ඒක C ට D ට දෙන්නටම
Yes.
බලන්න ඕනේ.
Yeah. Hub will now when bridge send a message, right? Bridge, now let's say A is trying to send this purple color message to C, right? So A will send it to hub 1, right? So hub 1 will send it to B and bridge, right? So when it comes to bridge will look at, okay, this message is for C, right? C is in my other side, not in the side 1, it is in side 2. So the message is coming from side 1, so I have to pass it to side 2. So it will pass it to side 2. So when it comes to hub 2, it will do the normal work, right? Hub will send it to both, right? Hub will send it to both. So the only advantage of bridge is it is actually dividing the network to two parts, right? So if this bridge was not here, even the messages going from A to B will go to C and D, right? So this yellow color message also will go to C and D if this bridge was not here. Now when the bridge is there, so it is actually breaking this hub network to two parts, right? So only if something has to go from this side to this side, it will go, right? Otherwise it will not go. Okay, so it is limiting some part of that unwanted traffic. Now if assume this bridge was not here, then definitely A to B message also goes to C and D, right? Which is not required. So with the bridge, you can stop some amount of unwanted traffic. Okay, I hope it is clear. To answer your question, yes, after it comes to hub 2, it will go to both, right? We cannot stop that now because anyway hub will do the normal hub operation, right? So but the bridge has the intelligence to limit at least some of the unwanted traffic, right? So we will quickly look at how the bridge does this, right? So bridge has something called a routing table, right? Something called a routing table is there. Routing table is built to record the segment number of addresses, right? So usually bridge should have an idea what are the layer 2, or we call layer 2 addresses usually MAC addresses. What are the MAC addresses in the segment 1 and what are the MAC addresses in the segment 2, right? So if destination address in the same segment as the source address, stop transmit. For example, you get a message, right? You get a message to bridge from segment 1, that is the destination MAC address is also in segment 1, right? So then you stop, right? For example, if this person is trying to send some message to this person, if the bridge gets that message, it will stop because he knows both these people are in this segment, so they must have already got it. But if you are getting a message from segment 1 to a MAC address in segment 2, then it will pass, right? So for that you need something called the routing table. So in that routing table, what will be there will be segment 1, what are the MAC addresses, segment 2, what are the MAC addresses, right? So that is the information bridge needs. So how do they take it? How do they get it, right? How does this routing table or switching table is built? Based on the addresses of sending computers, right? New addresses are added if they are not in the table, right? So for example, let's say, take a small example. Let's say this computer 1, right? We'll call it as 1, right? So 1 is sending a message to 2, right? 1 is sending a message to 2, right? So then this one message will go to here and will go to here, now there is a hub, there will be a hub for this. I'm not showing the hub. Like, let's assume the bridge also get the message, right? For this to happen, there should be at least a hub here. So let's say somehow the bridge also get the message, right? So in the message, what will be the sending MAC address? Now, one is sending a message to this computer, right? First, I will clear this, right? Let's assume now what is happening is this is 1, this is 2, this is 3, right? Now what is happening is 1 is trying to send a message to 3, right? So that message will go to 3, to 2 and to bridge, right? So that is what will happen now. If it is a bus network or you are in a, if you are connected to a hub, that is what will happen, right? So this 1 to 3 message will come to bridge also, right? So the bridge can look at the next hop addresses, and like layer 2 addresses, it can look, right? It can understand. So in this message, what will be the layer 2 source? Now layer 2, there are 2 addresses, right? Next hop address and who sent it. What will be the layer 2 source? 1 to 3 message? Yes?
Hmm. Three.
Source, not the destination. Source. Who sent that message?
One.
Now when you take a message, right? Remember when layer 2 device at the message, at the details, we put the next hop address, next hop MAC address. Let's say next hop MAC address is 3, no? And then you also put who is sending this message. Who is sending the message? This message?
One.
Who is sending?
One.
1, right? So then the source address will, I'm talking about layer 2 now. Layer 2 sender address will be 1, right? So this packet will come to bridge. So then bridge can understand what? Who is in segment 1? 3 or 1? Bridge can look at the sender's address, right? So if this came from this side, right? And it has come from 1, that means 1 is where? In segment 1 or segment 2? Segment 1 is this part of the network, segment 2 is this part of the network. Okay,
Segment
so
one.
segment 1, right? Because it came from this side now. So if it has come from some computer called 1, that means 1 is in segment 1. So it will update its table. Okay, 1 is here, right? And then let's take another example. Let's take another example. 2 is trying to send some information to this computer, right? We don't know, some computer, right? So 2 is trying to send some information to that computer. So this pink color packet will come here, right, to the bridge. So here, what will be this sender?
Two.
Sender's address will be 2, right? So that means the bridge will understand, okay, 2 is something called 2 is also in the segment 1, right? Again, let's say this computer is trying to send some information, sorry, this one is trying to send some information to here, right? So this orange color packet, sender will be 3, right? So that will come to here, come to the bridge, right? So when that packet comes to bridge, okay, bridge understand, okay, somebody called 3 is in segment 2 because this sender 3 packet with the address sender as 3 came to to me from segment 2. So that means 3 is in segment 2. So like this, the bridge will at the initial part, at the initial stage, it will make this switching table, right? So whenever new computer is added, when that computer send a message, this computer's address will be added to the switching table, right? So that is how the bridge will build the switching table. So after making the switching table, so it will take a decision whether to pass the message or not. For example, if you get a message from segment 2, right, that says this has to go to,
Madam, sorry, madam. Sorry.
yes,
Hello.
yes,
Sorry, madam. Mama, bila dia akan kata
yes,
saya.
yes, you can ask. You have a question? Not very clear.
යුනිවර්ටෙක් මේ පේජ් එකේ මැඩම් රිපීට් එක්සෑම් මේ ටයිම්
Can we discuss
ටේබල්
this
එකක් දාලා
later?
තියුණා.
Yeah. Can we discuss this later after I finish the lecture? You ask it when I finish this lecture, okay? Right? Because then otherwise this will get this discussion will get distracted, right? So you can ask. I will answer your question when I finish the lecture, right? So this is how the switching table will be made, right? So the bridge will make the switching table, right, according to this. So before first of all, if you send a message, sometimes the bridge will pass it to the other side because it doesn't know where that computer is, right? So after building up the switching table, according to the switching table, it will stop the unwanted data, right? So hope it is clear. Any questions? Any questions?
No, madam.
Right. So then now we look at collision and broadcast domains, right? Collision and broadcast domains. Now, let's say A is trying to send a message, right? B is trying to send a message. Not to each other, right? If it is each other, this is a different question. So we'll assume A is trying to message to somebody and D is trying to send a message to somebody, right? So is there a possibility of getting a collision? A is sending a message, right? Let's assume it is sent to B, right? It is sent to B. So he is sending a message that will go here, right? But will this orange color message pass to the other side? Will this orange color message go to the other side? This one will go to the other side. What do you think?
No, madam.
No, right? Because the B is already this side, right? So it will not go here, right? So which will tell us that if D is trying to send a message at the same time, right? Let's say D is also trying to send something. So this orange color one definitely won't reach here, right? Orange color message will not reach here most of the time, right? Unless it is for D or C, right? If it is for D and C, there is a possibility, right? But if it is for somebody else, it will not come here, right? So the probability of getting this one to this side is low, right? So we say now A and D are in two collision domain. Why? Because A's message, we don't have 100% probability that D also will get, right? Unless it is for C or D, it will not come, right? If it is for B, it will not come. But in the previous situation, we were 100% sure when A is sending a message, it will come to D and there will be a collision, right? But here, if it is only for C or D, it will come. Otherwise, it will not come, right? So then we say A and B are in one collision domain, C and D are in one collision domain. For two people to get into one collision domain, there should be 100% probability when A is sending some message and D is sending some message, they two will meet, right? But in this situation, because bridge is stopping some messages, there is no 100% guarantee that A and D messages will meet, right? So then this one part of the bridge will be one collision domain, other part of the bridge will be other collision domain. Now for C, if you take these two devices, when C sends something, definitely D will get it because hub is going to definitely send it to D, and if D also send a message at the same time, there will be a collision either at this place or this place, right? So because of that, now you can see if all four were connected to one hub, all four will be in one collision domain. But because of the bridge, now A and B are in one collision domain, C and D are in one collision domain. Is it clear? Why now they are in two different collision domains? Is it clear? Any questions?
Excuse me, madam.
Yes.
මඩ ඔතන මැඩම් අපි දැන් හබ් දෙකක් ඉන්න දෙපැත්තේ මැඩම් තියෙන්නේ කියන්නේ
Oh,
සයිඩ් A
yes.
සයිඩ් B
Yeah.
කියලා.
Yeah.
අපිට මැඩම් බැයිද ඩිරෙක්ට් හබ් එක නැතුව දෙපැත්තේ මේ ඩිවයිසස් දෙක කෙලින්ම බ්‍රිජ් එකට කනෙක්ට් කරන්න?
Bridge එකේ ports දෙකයි කියලා මම කිව්වනේ.
ෂුවර් මැඩම්. ෂුවර්.
Yeah, bridge is only to do this purpose only, right? So if you want other operations, there are other devices for that, right? So bridge is usually a low cost option of stopping this unwanted traffic, right? Bridge only has usually two ports, right? You can only connect two networks from two sides because that's called bridge, right? So it is only connecting two sides and limiting this unwanted data coming from the one side to the other side, right? So right, so it's a good question, right? So bridge only have only two paths, so you cannot directly connect devices to it, right? So collision domain, now one collision domain is divided to two, but broadcast domain, right? Let's say A is trying to send a message, this has to go to everybody, right? Broadcast message is that, no? Now let's look at that option. Now A is trying to send a message, this purple color message is coming. This has to go to everybody, right? So what does the hub do? It will send it to B and it will send it to bridge. Then what does this source MAC address says? Everybody. This has to go to everybody. So will the bridge pass it to the other side or not pass it? If it says it has to go to everybody, pass, right? You have to pass because there are other computers this side, right? So it will pass. So then again C will get it, D will get it, right? Because the hub anyway forward everything, right? So right, so then that means A, B, C and D are in one broadcast domain, right? So all these four computers are in one broadcast domain, which means when one computer sends a broadcast message, remember a broadcast message, okay? When one computer sends a broadcast message, that will definitely come to all these four devices, right? So purple color one shows the broadcast domain, and the two red color ones are the two collision domains created by the bridge, right? So bridge divides the network into two collision domains, but the broadcast domain will be one. Everybody in the network will be connected to one, will be in one broadcast domain. Okay?
මැඩම් හබ් කිහිපයක් තියෙනවා නම් එතකොට bridge to bridge connect කරලා ගන්නේ?
That will depend on the requirement. You can connect, there are other devices also you can connect. Bridge වලින් ඒ කියන්නේ ඔයා කියන්නේ කොහොමද? මට තේරෙන්නේ නැහැ. මෙතන තව
හතරක් වගේ තිබුණොත්
මෙහෙම තව හබ් එකකුයි මෙහෙම තව හබ් එකකුයි තිබ්බොත් එහෙම වුණොත් ඕනනම් මෙහෙම බ්‍රිජ් එකක් දාන්න පුළුවන්. නැත්නම් මේවට වෙන ඩිවයිසස් තියෙනවා කනෙක්ට් කරන්න පුළුවන්. ඔහොම ටික ලොකු වෙනකොට අපි බ්‍රිජ් එකක් දාන්නේ නැහැ. තව අපි දැන් ඉස්සරහට ඉගෙන ගන්න. තව ඩිවයිසස් තියෙනවා ඒ වගේ කනෙක්ට් කරන්න පුළුවන්. හරි මෙහෙම කනෙක්ට් කරන්නත් පුළුවන්. මෙහෙම කනෙක්ට් කරොත් වැඩේ තියෙන්නේ දැන් මේ බ්‍රිජ් දෙක අපිට එකට කනෙක්ට් කරන්න බෑනේ. ඒතකොට මේගොල්ල මෙයාගේ මෙයා මේ පැත්තේ තියෙන හබ් එකේ ඉඳන් මේ පැත්තේ මේ දැන් අපි හිතමු මේක හබ් 3 කියලා. මේක 4 කියලා. එතකොට 3 අපිට 3 වල ඉඳන් මේ 2 වලට මෙසේජස් එවන්න බැරි වෙනවා. කනෙක්ෂන් එකක් නැහැ. මෙතන තව බ්‍රිජ් එකක් දාන්න බෑ. හරි? ඒ කියන්නේ two different networks, then you can use a bridge, right? But if you want to connect these 3 and 4 hub to this other network also, then you need separate different devices, right? So we will learn what are the other devices. Right. Specifically, if you have this type of two hubs to be connected, then you can connect a bridge and then stop that unwanted traffic going from one side to the other side. That will depend on the application and the requirement, right? අර මම කිව්වා වගේ අර වගේ තව ඒව අතරෙත් connections හදන්න ඕන නම් bridge එකකින් කරන්න බෑ. මොකද bridge එක හැම වෙලාවෙම input out දෙකයිනේ තියෙන්නේ ඒකෙන්ද. එහෙනම් අපි ඊට වඩා advanced devices තියෙනවා. ඒ වගේ device එකක් connect කරන්න ඕන. Okay, right. So then we come to the next one. So any questions about hub and switch? Sorry, hub and the bridge before we come to the next one? Next one is switch, which is the most commonly used network device. Any questions? Okay, so then we'll move to the other part. Switch. A network switch is a device that connects the devices together on a LAN, right? So usually if you are in one network, we say if you are in a one network or one LAN, right? Remember we learned about LAN. LAN means usually all the devices in one building are usually called a LAN. So if you are in one LAN, usually all of you will be connected to one switch, right? Most of the time. A switch is similar to bridge but usually interconnects devices, not network segments, right? Remember that is the difference. Now here you can, now that is the question somebody asked, can't we connect all these four devices to the bridge? Sorry, to the bridge, right? We take out hub 1 and hub 2 and connect everybody to the bridge, right? So that is that possible? That is what you asked. So usually bridge cannot do that because bridge only connects network segments. It cannot connect devices, right? So that is the operation of bridge. So if you want to do this, the thing that you asked, then we need a switch, right? So we need a switch. A switch is similar to bridge but usually interconnects devices, not network segments. Switch work at much faster speed with many additional features than a bridge. Switch run in the full duplex mode, which means that hosts connected to a switch port can transmit to the switch at the same time that the switch transmits to them, right? So this is important. It is working in full duplex mode. So which means, let's say you are a switch and then there is a device here, then somebody sends data and the switch also sends data. This can happen without a problem, right? This can happen without a problem. So we say if the switch runs in full duplex mode, both of the people can send data without an issue at the same time. An Ethernet switch usually works at the data link layer, that means layer 2, right? So which means it can understand the layer 2 addresses or the MAC addresses, right? Sorry, there is a small mistake here. If you have the note, please correct this. This should be switch. Right, so if the switch has the full duplex mode, then this is also can be done without a issue, right? Right, now let's look at how switch operates. It manages the flow of data across a network by inspecting the incoming frame destination MAC addresses and forwarding the frame only to the host for which the message is intended, right? Now, usually like the bridge, right? Now, bridge had segment 1, these are the MAC addresses, segment 2, these are the MAC addresses, right? Now, in a network switch, if you see, this is the table it will have. We call it source address table or SAT table. So it will have a message or it will have the information. Now this switch has 4 ports, right? 1, 2, 3, 4. So first port the computer's MAC address is this, right? So A's MAC address switch knows, right? Switch has some, right, like that. I explain you how that bridge made the routing table. So same way, switch will also build up its routing SAT table the same way, inspecting the incoming packets, right? So it will make a table. Okay, port 1 is connected to this MAC address. That means A's MAC address, right? Port 2 is connected to this MAC address, right? Sorry, 7F is this one, no? Port 2 is connected to this MAC address, this MAC address. Port 3 is connected to this MAC address, B's MAC address, and port 4 is connected to this MAC address, right? So this data base is inside the switch, right? So now let's say A is sending a message to B, right? A is sending a message to B. So in this message, what will be the next hop address? If A is sending a message to B, what will be the next hop address? Yes? Any idea? A is sending a message to B. So what will be the next hop address in this B, or layer 2 address in the B? Destination, layer 2 destination. Yes? A is sending a message to B, right? A is sending a message to B. So when A send a message to B, what will be the next hop address A will put?
B MAC address.
B's address, right? Because it has to go to B, right? So they are in same network, no? So you will put B. It has to go to B, right? So it will put the B's MAC address. So B's MAC address is this 11D256 this, right? So in the layer 2, if you see the layer 2 destination, it will be this address, right? So this packet will come to the switch, right? Now switch will look at its table and try to see which port is connected to this MAC address. Which port is connected to this MAC address. So it will look at that and identify, okay, port 3 is connected to this 11D256 address, right? So A is sending a message to B. So A will put the next hop address as B's MAC address, right? So B's MAC address is this 11D256 something. So when this frame comes to the switch will see, okay, this has to go to this 11D256 address. So which port of mine is connected to this? So it will look at the SAT and then identify the port. What is the port? Which port is connected to 11D256? Yes, port 3, right? So from this table you can see it's port 3. So it will forward it to port 3, right? Port 3 is the port connected to B, right? Right? So it will go to port 3, right? So like that, when you get a message, now hub, what did it do? When hub get a message, it will just forward it to everybody without looking at anything, right? But switch is not like that. It is more intelligent. So what it will do, it will look at the destination MAC address. So the MAC address receiver, layer 2 receiver, and then forward it to the layer 2 according to the table. Is it clear? So this SAT table will be updated on the go, right? When more computers are added, or the computers, let's say you remove this A and connect another computer, so that will have a different MAC address. So immediately the switch can update this SAT table, right? So we say it's a dynamic table. It's not constant. It will always it will be updating, and then without unlike the hub do without copying it to everybody, switch has the intelligence to identify to which MAC address it should go, right? So which port it should go by matching the MAC addresses, right? So then we say layer switch is a layer 2 device. Why? Because it can understand the layer 2 addresses or the MAC addresses and make a decision to which port exactly this should go. Okay? So any questions? Any questions? Any questions? No, right? So it's basically very simple. It will look at the MAC address and match it with the table and forward it to the only the correct port, not to everybody, unlike the hub, right? So then switch you can use basically to connect many number of computers. Usually we have 24 port, 48 port switches where you can connect number of devices together without any issue, right? And if you want, you can connect hubs together also, right? Now in this situation, if you want, you can connect a switch here, right, without a bridge. Now normally we don't do that because then it is no point, right, because bridge will be less expensive. So you can, what you can do is, as somebody asked you, take all these out and take one switch and connect these 4 devices together, right? So that is the easy option. So then why are we using these hubs and bridges? Any idea? Why are we not using a switch and just still using hubs and bridges? What is the reason?
Price,
So,
material price, or
no, there is a small difference, but not specifically that. Basically, the cost, right? Because if you have now hub is layer 1, no, so that means it doesn't have any intelligence. Bridge also has only, although it is layer 2, it has only limited capability. So the cost of these devices are low, right? And sometimes if you want to have very small network like 5-6 devices, no point investing on a switch, right? You can do the same thing with the hub without much effect on the functionality, because small number of devices, no, even you get a small delay, that will not be a much issue ultimately for the user, right? So for small networks, better to use these hubs and bridges arrangements. But if you are going for more advanced systems, then definitely we need switches, right? So that is why we still use the hubs and bridges, because small networks sometimes maybe, let's say some small office where you have about 5-6 computers to connect, right? So then without going for a switch, you can go for a hub, right? Because although that collisions happen, that will not be a much of an issue, right? So because of that, we use switches, hubs and bridges for small applications. And when you have larger or more advanced featured of applications, then we go for a switch, right? So if you look at the collision domain, so I told you, usually one computer, right? Even if you have full duplex mode, these two, you can do this communication also without an issue, right? So then we say one computer is in one collision domain, right? Basically you don't have collisions then, right? So A is in one collision domain, B is in one collision domain, C is in one collision domain, D is in one collision domain. Why? Because when D is sending something, A is sending something, there is definitely, these two will not get any collision, right? And B and C are sending something, no collision, right? Because it will only send it to the required person, no, right? So then no collision, right? So all for each device in the network connected to the switch will be in separate collision domain. So if you have 5 devices connected, 5 collision domains. If you have 10 devices, 10 collision domains, right? There won't be any collision between this computer and this computer, right? When both of them are trying to send the same time, no issue, everybody can send at the same time. Then broadcast. What about the broadcast? Let's assume A is sending a broadcast message. Broadcast message means send this to everybody. A is sending a send this to everybody message, broadcast message. Then who will get it? Who will get it? Broadcast, it has to be sent to everybody. What will the switch do?
broadcast to everyone.
Broadcast to everyone, right? So here, when you send this one, unlike this MAC address, so you don't put this kind of a MAC address there. Why? Because it has to go to everybody. No, so I told you there is a special way you communicate that, right? Special address you can put. So that address will be put and sent. So then that means the switch will understand everybody should get it, right? So this person will get it, this person will get it, and this person will also get it. Switch will forward it to everybody, right? So that means A, B, C, and D all are in one broadcast domain, right? Everybody is in one broadcast domain, but these 4 people are in 4 collision domains. Why? Because each of these computers can send the data simultaneously without getting a collision. Because switch don't, unlike the hub, switch don't copy everything to all the people. It will only send it to the required person. Okay. Right. Right. So I will give you a small example from what we have discussed up to now. Can you write down this question? Okay, so please try these two questions. Okay, can we discuss? So first one, what is the network device that you can use? Yes,
Hub
first.
and bridge.
Hub.
Yes, so no need to actually use a bridge because only 5 computers and a printer, no, so that means about 6 devices, right? So if you want a bridge, if you are using a bridge, then you need 2 hubs, right? So no need to go for that kind of very complicated one, right? So you can use a hub and connect the 6 devices here, right? So if you specifically more concerned about the speed, then you can use bridge. But if you are using a bridge, remember you need 2 hubs, right? So you need to connect 3 devices each hub and then connect 2 together with a bridge. So which will be a little bit more expensive considering you have to only connect 6 devices. So then you can best use one network device, a hub, and then connect the 6 devices together. Okay, right. So the next one, how to do? How to do the next one?
2 hubs and bridge or switch.
Yes. So 2 hubs and a bridge means what are the devices you are going to connect to one hub?
5 computers.
One
Sorry,
floor.
one flow, right? So one flow devices we can connect to one, right? So there will be 10 computers here. Flow 1, right? You keep one hub at flow 1 and another hub at flow 2, and then connect these two with a bridge, right? So that is first option. Or else what you can do if you are using a switch? Yes, if you are
Yes.
using a switch, what do you do? Connect
All into a
all 20 devices to one
switch.
network switch, right? So which you can easily do because there are usually switches with 24 ports, right? So you can use one switch and connect everybody together. That is also possible. So how do you select which one is more effective? Depending on what? Now let's say this is A, no? Option A or B. Which one you are going to select according looking at what? Yes?
B.
No. Right. You are selecting B. Yeah. So why? Yes. Why?
Madam, if it is that mean if the office building is 2 department,
Mm.
it may be proper than is A, I think. Because
Uh,
if the department, if it is 2 departments, because they
Yeah, probability of sending details from one department to other
low.
department will be low. Yes,
Yeah.
yes, right, right. So that can be one arrangement. If it is like that, right? So if it is not like that, you can go for a switch, right? And the other thing you have to look at basically is the cost, right? So if you are using 2 hubs and a bridge, what will be the cost? And if you are using one 24 port switch, what will be the cost, right? So that also you can take into consideration because if you are having a switch, advantage you will get is the network will be very much faster than the first application. But looking at the cost of the two systems also, you can make a decision whether you are going for A or B, right? So B will be obviously more technically better solution, but looking at the cost, if it is too much of a cost with when considering 2 hubs and bridges, then you can go for A, right? And as you said, if the two departments I mean, not departments, if the probability of getting data from one flow to the other flow is less also, then A will be a better solution, right? So that is correct, right? But anyway, if you have B option, even this hub operation now, let's say one person is sending to second person, then still all these people will get it, no? But at the switch, you will not happen that, right? If one is sending to two, only one and two will get the message, right? Not, I mean, only two will get the message in the option B. But in this situation, when A is sending something, all the people here will get the message, right? So anyway, so looking at the cost and the expected level of performance, you can make a decision. Okay, so I hope it is clear. I just gave you this example to summarize what we have discussed up to now.
මැඩම් ඕවගේ කොස්ට එක ලොකු වෙනසක් තියෙනවද බ්‍රිජ් එකයි හබ් දෙකයි
Yeah, so compared to a switch, sometimes two hubs and a bridge will have, now what you have to look at is two hubs and a bridge, what is the cost, and the network switch, what is the cost, no? Right? Sometimes there is a possibility that network switch is expensive than the addition of these three. Because hubs are basically non-intelligence devices, very cheap, right? Hub is like I told you, it's a multi-port repeater, right? No intelligence at all, just copying what we get from one device to the other ports, right? So they are very less expensive. Network switches are expensive because they have intelligence, right? Intelligence means you need more features. That means the cost will be more, right? So we'll have to look at the cost also when making a decision. Okay.
Okay.
Right. So then we'll move to the other topic, router. Next device that we are going to discuss is the router. So router, we say it's a layer 3 device, right? So router is a network device that connects different computer networks, right? Remember, this is very important. Router connects different computer networks, right? 2 or 3 LANs. Remember this example that we discussed last week, where I explain you how a packet travels from one place to the other place. So see here, the routers, they are connecting what? Router 1 is connecting what to what? Yes? LAN 1 to LAN 2, right? It's connecting two computer networks together. And router 2 is connecting LAN 2 and LAN 3 together, right? So routers usually connect networks together, right? So that means router should be more intelligent than a switch, right? So we say routers are layer 3 devices, right? So router is a network device that connects different computer networks by routing. Routing means what? Now remember, now a packet came from this side, the previous example, right? A packet came from this side and you had to make a decision, the router had to make a decision whether you have to send it to this side or this side, right? So looking at final destination address, it identified it has to go to each one of the sides, right? So like that, routes, right? So it sends the packets to different routes, right? So that is called routing packets from one network to the other. When data packet comes to a router reads the address information in the packet to determine which port the packet will be sent, right? So when you send a packet to here, it will look at the information on the packet and make a decision whether you should send it to this side or this side, right? Route is considered layer 3 device of the OSI model because its primary forwarding decision is based on the information of the layer 3 address, destination IP address, right? Remember, now switchers always looked at which address? Switchers looked at which address? Yes? Now switchers, now we learned just now, right? What is the address switchers looked at? What is this address called?
MAC address.
Yes, layer 2 or layer 3? This address. Layer 2, right? Next hop address, right? It looks at the next hop address. So if you are routing or if you are sending data to computers within the network, right? usually looking at the MAC address is enough, because you just send the next stop, no? So next stop means you have to only send it to somebody who is in the network, right? So then looking at the MAC address is okay. But if you are thinking about the final destination, now when the router gets this packet, it has to make a decision which path we should go to the final destination, right? So final destination is somewhere here, right? So I'm talking about this example. I will go to that then explain. Right. So let's say, now remember this example, the packet, right? The packet, because this packet has to go outside from LAN 1, we put this address and send it to the router, because then only this has to go here, right? So now the router has got it. Now he has two options, where this one or this one, right? So the MAC address of this one does not meet, go to this two, right? So we don't know, right? So then you have to look at, because you cannot now we have to make a first, without to identify what is the next stop, first you have to identify where this should go ultimately, right? So then only you can make a decision whether you should send it to this side or this side. For example, if you remember that letter example I told you, when you get a letter to Colombo main post office, it has to look at not the house address or the street address, no, it has to look at where this should go, like Colombo, Kandy, and then make a decision where to which side this should go. Like that, the router also looks at the final destination, where this should finally go, right? So then to do that, you need layer 3 intelligence, right? Because final destination details are in the layer 3 packet, not in the layer 2 frame, right? So you should have the intelligence to look at the final destination and make a decision whether you should send it to this side or this side. And you should have the understanding or the database to identify if this has to go to P. So P is somewhere here, so I have to forward it to LAN 2, right? So that information also should be available with the router. So routers always look at the final destination, right, to make the decision where this should be forwarded. So that means it's a layer 2 device, right? Layer 3 device. So why do you need the final destination details? Because you are talking about sending packets from one network to the other network. So when you send data from one network to the other network, your concern is not the next stop, right? Next stop means within your network where this should go next. Final destination means finally where this should go. So that most of the time will be out of your network, right? If the packet is coming to a router, that means that packet has to go outside from the network, right? So then you have to look at the final destination. So final destination means that to look at the final destination address, you need the layer 3 intelligence, right? So router is considered layer 3 device because it makes the decisions looking at the destination IP address, where this should go finally. IP address is what we talk in layer 3. If two hosts from two different networks want to communicate with each other, they will need a router between them, right? For example, now I told you that previous example, right? 2 floors, 20 computers. So we connect everything together. So switch is enough, right? So we have a switch. Then you send information from one computer to the other computer. It will look at the MAC address and say, because switch has the information about all the devices that is connected to him. It knows the MAC addresses of all the devices. Let's say you want to send information to some another computer that is in a different building, right? Let's say you are in here at your office and you want to send this some computer in stores somewhere else in another city, right? So can you connect a switch to this? No, because this is somewhere else, physically different location, right? So you cannot put a cable from your building to this building in Kandy and connect, right? So then what is the option we usually have?
Yes, switch.
Hmm?
Router.
Router means router. Practically, if you do this, how do you do this? Just think of a practical application. Now you have, let's say, 20 computers in your office, right? You are in Colombo. And then you want to connect your network to a branch office in Kandy. How do you do that? Do you draw a cable from your office to Candy office? No. Then what do you use usually?
From any network.
Internet.
You use the internet, right? You use the internet. So internet means what? You are in one network. You are going to connect to a large network other side, right?
Amma.
So you connect your, it's like this, no? What we do is, this is your network, your Colombo network, right? You have your computers, right? And then this is your Candy network, right? So if you can connect your own cable from Candy to Colombo, that is fine, right? So, but we cannot do that, right? So that is not possible. So what do we do? As somebody said, we connect to
Internet.
what? Internet, right? You connect to internet. So internet connection means you are connecting to a very large network. Network means very like networks of network, and through that you somehow find a path from Kandy to Colombo, right? So usually what you will do is you will have a router here at your building, and then you will connect to, let's say, Dialog or SLT network, right? So SLT or Dialog network will have number of routers. So some way they will provide you the connection to your router at your handy office, right? Right. So see here, now you are in one network and you want to go to some other network. So definitely you need a router, right? Because if you want to connect one network to the other network, at the end there should be a router, right? So routers always look at, now MAC addresses can do the route. Looking at the MAC addresses, you can do anything within the network, right? If you are going outside from your network or outside from your building, that means completely different place, then you have to connect to another network and go to make that connection, right? Because you cannot physically make connections from Kandy to Colombo, right? So then you need to connect to other networks and then find out the path. So then you need routers, right? Hope it is clear. So if two hosts from two different networks want to communicate with each other, they will need a router between them, right? So you want to communicate from to your Candy office. So that means you are in two different places, so two different networks. So definitely you need at least one router. But in actual conditions, not only one router, you need number of routers. From your router, you connect to SLT, some sub router, and then you go through some we don't know, right? Something will happen in their network, and then finally you will get a connection from Candy SLT premises to your Candy office, right? So then the connection will be there, right? So when you connect within networks, if you want to connect two networks together in any situation, you need a router, because then you need to look at the IP addresses to send the messages, right? Because switches can only look at MAC addresses. So switch knows only the MAC addresses of the people who are directly connected. So if you are directly connected within one network, switch can handle that. But if you are talking about somebody who is far away, switch don't know what to do, right? So then, because switches cannot understand the IP addresses, right? So IP addresses are required when you are communicating within the network, in between networks, right? So then you need a router. So I hope it is clear. Any questions? Any questions?
No, madam.
Right. So others, anything you want to clarify? Right. So then look at this example. Right. So I just want to see. Right. So router example. A router connects three networks, right? So you are in, this is one network. So only one computer is shown, but there may be some other computers connected, right? And this is in one network. There can be some other devices. It is not shown for the simplicity, right? So basically router is connecting three networks together, right? Router connects three networks. If a computer A, right, A computer's IP address is 192.168.0.0, needs to communicate with computer B, right? So I'm going to erase all this. if A wants to communicate with B, its IP address is this, who is in another network, the data has to be sent to the router in the network, default gateway. Okay. Sorry, there is a small mistake here. Please correct in your note. In the network. No need, this is not the IP address, right? This you have to, sorry. Please delete that IP address, right? So that is not correct. Sorry for that. Right? So, first of all, I told you, now in this one, this we discussed that day also, right? So now A wants to send something to B, right? Now A knows, before sending, A knows this B is not inside your network, right? Because usually you have the computers each other know who are the devices within the network, who are the devices not in the network, right? So then it has an idea. This has to go outside from the network. So if you want to go outside from the network, where should it go first? To this router, right? So it should go to this router. So first step is that. So the packet, this packet will come from here to here with the next stop address as the router, right? Now router looks at the packet and see, okay, this is my MAC address. So that means this is for me, and opens. And then looks at the, now you have opened the layer 2 message and then looks at the layer 3, right? Now layer 3 will have the final destination, right? So what is the final destination address it will have? Can you give me 1 minute? Yes. Okay, right. Sorry that I had to answer this call. It was an urgent message. Right. So we were talking about this, right? Okay. So I told you that day, that example also, if you want to go outside, if the computer knows that it has to go outside from the network, definitely it will send it to the router, right? So this router, we call it the default gateway, right? So usually when you make a network connection, you can try in, you can see in your computers also. Wait, I will show you. In your network settings, a default gateway is given, right? When you put your IP addresses and all, usually a default gateway is given. Default gateway IP address. So default gateway IP address always mean the IP address of the router that you are connected, right? So
Madam,
any. Yes.
madam,
No, I'm not sharing it. Wait,
sorry,
wait.
madam. Okay.
Yeah. Right. So I'm trying to open the settings. So I'm just explaining you. Right. So usually what will happen is, now if you are, now let's say I'm in university network now. So I want to go to internet, or I want to go to I want to connect to some other network. Then I have to be connected to a router which is at the end of the university network, right? So where university connects to SLT or any other service provider and get the connection to other side, right? So then uh, when we make that connection, when you set up the IP addresses and all, usually you with the IP address you again give something called the default gateway, right? So default gateway means the IP address that you have to go when you want to go outside from the network, right? So I just wanted to show you that. I'm not sure. Right, give me 1 minute. I will try to show you. Right. So here you cannot see the IP address because now these IP addresses are, everything is taken dynamically. That means we are not going to set it and it will be sent by the router, I mean the network itself. But if you see here, right, can you see this TCP IP version 4 properties window?
Yes, ma'am.
Right. So there you can see here usually something called, now this is saying obtain IP address automatically. That means we are not able to set it, right? But if you set it, you have to set the IP address and default gateway, right? So see here there is something called default gateway. So default gateway means the IP address to which you have to send the data if you want to go outside from the network, right? So default gateway means always the IP address of the router that you are connected. So if you see here, you may be able to see, right? So this is my IP address. IP address is this. This is my IP address. And then here there is something called default gateway 92.192.168.61.253, right? So that is the place you should go if you want to send something outside from the network, right? From the network that I have connected, if I want to go outside, this should be that. So that is called default gateway. Okay. Right. So in your computers also you can check what is the default gateway. So if you are connected to your home network, it will show the IP address of your router to from where you are connecting to other side. Right. So then this packet will go to the default gateway, right? Which means it will come to this router. And now router will look at the final destination, right? So final destination is, what is the final destination? Computer B's address 10.10.1020, right? 10.10.1020. So then the router will see, okay, now the packet has come from this side, right? It has come from this side. So it has two options, either to send it to this side or to send to this side. So from its information, it can understand 10.10.20 is in this network, right? So then it will forward the packet only to this side, and this computer or this network will not have any, they will even don't know that this communication has happened. They will not get anything, right? The router receives the packet, compares the packet destination IP address to the entries in its routing table, right? So there is a routing table. As I told you, the switch has a SAT or source address table. Like that, they have something called routing address, right? So it has basically something like this. So port 1, right? Now let's say these are port 1, 2 and 3. So port 1, what are the connected networks, right? So it only not says about this network, right? So for example, let's say from like this, let's say you have the router and you have this port 1. So port 1 is connected to one LAN, right? And then it is connected to another LAN, right? So let's say this is LAN A and LAN B. So this will know, this router will know in this routing table. If I just give you like a very simply say, from 1 you can go to A, LAN A, and also to B, right? So the far away ones also it is knowing, right? So if you want to go B also, then you have to go to A and go to 1, right? So like that routing table is there, right? So from that routing table, it can, it's a little bit complicated to understand, but somehow it has the capability of knowing, looking at the IP address, which port to forward, right? So router receives the packet, compares the packet destination IP address with the entries in the routing table and find a match. Then the packet is sent to the interface associated with that network. For in this example, this packet will be only sent to this side, not to this one, right? So then B will get the message, but C will even don't know that kind of communication has happened. So routers basically looks at the IP addresses and try to find a match to which port it has to go according to the IP address or the routing table it has, and make a decision where it should go. So basic understanding is, if you have to go from one network to another network, basically you will have to go through the routers, right? So router is layer 3 device. Why? Because it makes the decisions on the IP addresses, which gives you the information about the final destinations. Because to router to find out which port it has to forward, it is looking at the final destination, right? So then that means routers will have like layer 3 intelligence, right? Now we are looking at the collision and the broadcast domains of a router. Okay, right. So now this is an example. You can see there is a router. This route is connected to, now you will little by little learn these symbols also, right? So this is a switch. This symbol we are using for switch. This is for router and this is for hub, right? So no need to specifically know them. I don't expect you to know the symbols, but when you see these pictures, like most of the time, you will be able to figure out, right? Usually routers are shown like this, switches are shown like this, these are hubs, right? So there are two hubs connected with one switch, and then there are some computers directly connected to the switch. Then another two hubs and connected to one switch, and these two switches are connected to the router. Okay, right. Now we'll look at the broadcast domains. Right? First of all, the collision domains. Now, if the two computers in one hub are in one collision domain, these two are in another collision domain, these two are in another collision domain, these two are in another collision domain. Right. And then each of these computers, right, they are separately in separate collision domains. Remember, we learned no switches two computers connected to switch are not in one collision domain because you will not get collision. So they assign separate collision domains, right? And this connection is one collision domain. This is also one collision domain, right? Now let's look at, so collision domains you have understanding, right? And then broadcasting. Now let's say this computer, this one is sending a message A, right? Sends a broadcast message. To whom it will go? Will it go here? Will it go to this computer? Broadcast.
Yes, madam.
Yes, right? Will it go to this computer? Yes, right? It will go to this hub? Yes, right? Because broadcast has to go to everybody. Switch send it to everybody, right? Switch will send it to all the people, right? And after that, now router is connected to some other router, right? Right? Router is connected to some other router. So after router receives it, router will not receive it, forward it to anybody else, right? Why? Broadcast messages are only within the network it is connected, right? So broadcast message means we want to send it to everybody in the network. So everybody in the network ends here, right? So router connects it to another network, right? So you are not going to forward it, right? So after this, router will not forward it to this side or this side. Understood? Why? Because the router means end of the network, right? When you come to the router, that means the end of your network. So after router, broadcast messages are also not forwarded. So a broadcast message sent by A will come here, here, to these two computers, and to router. But router will not forward it further. So your broadcast domain ends here. Same way here, right? Let's say this computer sends a message broadcast. From the hub, it will go to the switch and switch will send it to this hub and these two people will get it. This computer will get it. The router will get it. But after that, router is not going to forward it more because broadcast messages are only for the devices within the network, not to the people outside the network, right? So then this will be the one broadcast domain, this will be another broadcast domain. For example, if A sends a broadcast message, that will never be received by this computer here. Why? Because you are in one network here, this is another network. Okay? Is it clear?
Yes,
Yes.
Right. So any questions? Anything that you want to clarify regarding this lecture? And then Padma asked some question about repeat exam. What is that? Padma, are you here? Somebody asked something, no?
Yes, madam.
Yeah, what?
Yes, madam. මේ ටයිම් ටේබල් එකක් දාලා දෙනවා මැඩම් මේ යුනිවර්සිටි පේජ් එකේ.
මොකක්ද ටයිම් ටේබල් එක? මොනවද තිබ්බේ මොඩියුල්ස්?
20 එකේ මේ ඒක පස්සේ තමයි දැක්කේ QS එක්සෑම් එකක් කියලා.
ඔව් ඉතින් QS එක්සෑම් එක ඕගොල්ලන්ට රිලෙවන්ට් නැහැ. ඒගොල්ලන්ගේ එක්සෑම් වෙනම තියෙන. ඒගොල්ලෝ වෙන ෆැකල්ටි එකක් නේ. අපිට සම්බන්ධයක් නැහැ ඒගොල්ලන්ගේ.
සේම් ඉයර්කින්ද මැඩම් මම
නෑ සේම් ඉයර් වුණාට ඕගොල්ලන්ට රිලෙවන්ට් වෙන්නේ BST එකක් නම් විතරයි. ඒගොල්ලන්ගේ එක්සෑම් වල අපි කිසිම සම්බන්ධයක් නැහැ. හරි ඒගොල්ලන්ගේ එක්සෑම් වෙනම ටයිම් ලයින් එකක් කියන්නේ අපේ එක්සෑම්ස් වෙනම යන්නේ. Okay, අපේ ෆැකල්ටි එකේ විතරයි අපි එකට තියන්නේ. ඒ කියන්නේ මෙකට්‍රොනික්ස් මැනුෆැක්චරින් බිල්ඩින් සර්විසස් කන්ස්ට්‍රක්ෂන් ටෙක්නොලොජි විතරයි එකට එක්සෑම් ෂෙඩියුල් කරන්නේ. එහෙම කරත් ඕගොල්ලන්ට ඒ එක්සෑම් අදාළ වෙන්නේ නැහැ. BST ඩිපාර්ට්මන්ට් එකේ නෙවෙයි නම් අපිට අදාළ නැහැ. Okay?
madam. Excuse
Right. Anyway, your exams we will let you know in advance when your exams are scheduled.
madam, results දෙන්නද madam?
Results out වෙයි. පොඩි කාලයක් යනවා මේවන්. මොකද මේ සැරේ issue එක වෙලා තියෙන මම දන්නේ ඔයගොල්ලන්ට සාමාන්‍යයෙන් තේරෙන්නේ නැතුව ඒක ඔයගොල්ලෝ අලුත් batch එකේ හින්දා. අපි exams ගානක් තිබ්බා online exams. ඒ කියන්නේ එක දිගට එක exam එකක් ඉවර වෙනකොට ඊළඟ එක එහෙම ඊළඟට exams ගොඩාක් තිබ්බා online අර ඔයගොල්ලන්ගේ exams තිබ්බ දවස්වල. ඉතින් ඒකේ හින්දා පොඩි backlog එකක් ඇවිල්ලා තියෙනවා. මොකද lectures limited ගානක් ඉන්නේ. ඉතින් ඒගොල්ලන්ට ටිකක් results out කරන්න චුට්ටක් delay එකක් තියෙනවා. මම දන්නවා දැන් ගොඩක් delay වෙලා තියෙන්නේ කියලා. ඕගොල්ලන්ගේ තමයි first choice එක තියෙන්නේ. ඔයගොල්ලෝ ඔක්කොම වගේ results උත් out වෙලා තියෙන එකක් දෙකක් පොඩි issues වගේක් තියෙනවා. කොහොමත් ඉක්මනටම ඔයගොල්ලන් එක තමයි ඉස්සෙල්ලාම release කරන්නේ. ගොඩක් ඉක්මනට release වෙයි. හරි අර ඒ issue එක වෙලා තියෙන්නේ මොකද online ඔයගොල්ලෝ online නෙවෙයි ලිව්වේ මං හිතන්නේ නේද? අනිත් එක්සෑම්ස් ඔක්කොම ඔන්ලයින් ලිව්වේ. දැන් ඒවයි මේවා වෙලා මොකද මේ බලන්න ඉෂුව එකක් තමයි තියෙන්නේ. ඔයාලගේ තියෙන්නේ මොකද්ද බලන්න සෙමෙස්ටර් 1 නේ. ඔයාගේ අවුට් වෙන්නේ සෙමෙස්ටර් 1 එකේ මොකද සෙමෙස්ටර් 1 එක ඉක්මනට අවුට් වෙයි. හරි. මේ මොකද ඊටත් ඉස්සෙල්ලා තිබ්බ එක්සෑම්ස් වගේ එකක් බෑක්ලොග් එකක් තියෙනවා. එහෙම ඉෂුව එකක් තියෙන. හැබැයි ඔයගොල්ලන්ගේ සෙමෙස්ටර් 1 එකේ හින්දා ඒක ෆිසිකල් නේ තිබ්බේ. ඒකේ මම හිතන්නේ රිසල්ට්ස් ඔක්කොම වගේ මට මතක විදිහට සෙමෙස්ටර් වගේ සෙමෙස්ටර් 1 නේ තිබ්බේ ඔයගොල්ලන්ගේ. ඔව් 1 ෆිසිකල් එක්සෑම් එකනේ තිබ්බේනේ. මම හිතන්නේ ඔයගොල්ලන්ගේ එකක් හරි දෙකක් හරි අර අනිත් ඒවා හම්බෙලා තියෙන්නේ. ගොඩක් ඉක්මනට රිසල්ට්ස් රිලීස් කරනවා. හරි කොහොමද ඉෂුව එකක් කරගන්න එපා. දැන් ඔයගොල්ලන්ගේ ඊළඟ සෙමෙස්ටර් 1 එක දැන් ගියා කියලාත් මොකක් හරි අපි හිතමුකෝ ඔයගොල්ලන්ට රිපීට් එකක් ඒ කියන්නේ ඒගොල්ලොත් එක CA කරන්න බැරි වෙලා හරි මොනවා හරි එහෙම ඉෂුව එකක් ඔයගොල්ලෝ ඒ කියන්නේ අපි රිසල්ට්ස් අවුට් කරපු එක වෙලා ගිය හින්දා වෙලා තිබ්බොත් ඒක අපි කරෙක්ට් කරනවා. අපි ස්පෙෂල් එකක් තියලා හරි ළමයින්ට අසාධාරණයක් නොවෙන්න ඒක කරනවා. මොකද මේ වෙලා තියෙන්නේ අර අපි මේ කොවිඩ් කාලේ තිබ්බ ඉෂුව එකෙන් ආපු බෑක්ලොග් එක හින්දා මේ රිසල්ට්ස් රිලීස් කරන එකේ ඩිලේ එකක් තියෙනවා. අර ඔයගොල්ලන්ට තාම සමහරට තේරෙන්නේ නැතුව අපි විසිටින් ලෙක්චරර්ස්ලාත් එකම විසිටින් ලෙක්චරර්ස් ටිකක් තමයි ගොඩක් මොඩියුල්ස් කරන්නේ. ඉතින් ඒතකොට ඒගොල්ලොත් අර මොඩියුල් දෙක තුනක් කරන හින්දා ඩිලේ එකක් තමයි තියෙන්නේ. හැබැයි ඔයගොල්ලන්ගේ මම දන්න විදිහට රිසර්ච් ගොඩක් ඒවා රිලීස් වෙලා තියෙන්නේ. මේ රිලීස් වෙලා කියන්නේ හම්බෙලා තියෙන්නේ. හම්බුන ගමන් අපිට රිලීස් කරන්නත් බෑ. එක්සෑම් බෝඩ් එකක් කියලා එකක් තියන්න ඕනේ. ඒකෙන් රිසර්ච් චෙක් කරලා තමයි රිලීස් කරන්නේ. ඒකින්ද පොඩි කාලයක් යයි. හැබැයි ගොඩ මේ කියන්නේ තව ගොඩක් කාලයක් යන්නේ නැහැ. Okay. Right. So then shall we take a break and now 12:10 no? At 1:05 can you come?
Okay, madam.
Right. So you have 55 minutes no? So 1:05 please join for the lighting lecture. Right. Thank you for joining there.
Thank you, madam.
Thank you, madam.